All right, let's continue our discussion of Chapter 3, the biomes. And I think we're on this one next, temperate shrublands and woodlands. Now, this is sometimes, as pointed out here, is what's known as a Mediterranean climate because there's a lot of this around the Mediterranean, but you do find it in different parts of the globe, as you can see from the map, the southeast, parts of the southeast United States, particularly the coast of Southern California. Again, a lot around Mediterranean, southern Spain, Portugal, Greece, Italy, Turkey, um, Australia, a little bit of parts of South Africa and South America. And so this is a habitat that is often characterized by dis somewhat distinct wet and dry seasons, as you can see in this example in Spain. In Southern California, they tend to have wetter winters and dry summers. Um, so you don't get extensive amounts of vegetation, um, and when you do, you tend to get sort of a, I wouldn't say a stunted forest, but it tends to be relatively small trees and shrubs. They don't have big, large forests by any means. Because of the dry season, they often have fires, and so a lot of plants are fire adapted. And because of the low vegetation levels, you tend to have relatively poor nutrient soils. These habitats often have quite a bit of topography, hilly kind of climates. And so yeah, you can see in Spain here, there's a slight difference in temperature, but it's warm throughout the year. But you can see in the middle of summer, it's relatively dry. And so during that period, in particular, when plant growth is going to be quite limited. And so here you can see in California and Africa some of these characteristic look of this Mediterranean climate. Um, all right, temperate deciduous forest. This is one that should be familiar to all of us because it's where we live. You can see a good chunk of the eastern United States, southern Canada, um, western and central Europe, parts of Asia, large part, a good chunk of China, Japan. So we're north of desert regions. Um, so that leads to this quite temperate climate. Again, you're going to have very times of the year when it's quite warm and times of the year when it's quite cold, below freezing to a certain extent, depending on how far north or south you are. Because of that seasonality and temperature, often have a lot of deciduous trees. Um, Tend to have lower diversity than the tropics, although there are a few organisms where there are exceptions to that. And all those trees and those leaves falling down in the fall helps to create some relatively fertile soils. These are areas that when you look on the map of human impact that have been quite agreeable to humans living in them over time. And so a lot of these forests have been removed and there's very little old growth or original forest left. Um, Now, when you travel through the eastern United States, though, you do see a lot of forest, but most of it is what we would call second or third growth forest. It's not the original forest left. Um, in fact, most of the vast majority of the forests in the east United States were cut down at one time as it was settled by Europeans, but a decent amount of it has grown back. And so again, characterized by those deciduous forests, changing colors in the fall, dropping their leaves. Um, so, and you can see in Japan that image, if we were to say that was here in the United States, you wouldn't be surprised. But again, other parts of the globe have this type of climate. Now here's a unique areas, temperate evergreen forest. So these are areas that, again, are temperate, cool, and warm seasons, but tend to get quite a bit more precipitation than your typical temperate area. Um, and as you can see, they're quite wet. They tend to be dominated by evergreens as opposed to broadleaf trees or these deciduous trees. And so that's a term we often apply to deciduous trees, is that they're what you call broad-leaved trees. That is, their leaves are nice and big, as opposed to evergreen trees like pines, spruce trees, fir trees. They tend to have needles, really thin um, leaves, and keep them around year round. Um, Tend to be coastal. Again, that helps to increase the amount of precipitation they get. Here as well, there's not a whole lot of the old growth left, although there's probably a greater proportion of it than in temperate deciduous forest. Um, Low diversity, those evergreens, those conifers tend to acidify the soil. Um, so here you can see in Australia, of course, the seasons are reversed there in terms of temperature and fairly high moisture levels throughout the year, although there's a bit of variation. Um, and so the Northern California, Southern Oregon and Washington State, those coastal areas, and here you can see in Argentina, on the very southern tip of Argentina, um, boreal forests, exclusively in the northern hemisphere, and you can see they're quite a bit further north, a good chunk of northern Canada, some of Alaska, the Scandinavian countries up here, and throughout Russia, the Siberia. Um, so it's pretty cold, short growing seasons, thus they have a long winter, dominated by as well conifers, the evergreens, lots of organic matter because of the short growing season. The organic matter, the plant material that does fall to the ground tends to not decay as quickly, and so it tends to accumulate over time. They're also where you tend to find these things called peat bogs, which form from peat moss, and moss is a type of plant that's low to the ground, and again, because of the long winter, it doesn't decay to a large extent, so it just builds up year after year. Um, here you can see we have a somewhat temperate climate, but you can see a good chunk of the year is quite cold, below the freezing point, so the plants go dormant. Um, Precipitation will vary a great deal around these areas. It tends not to be that too awful high, though. Um, and so they're dominated by relatively few types of trees that just go on forever, it almost seems, in these extensive forests. Um, a good portion of the original forest in this habitat is still left, although there has been increasing logging in these areas recently. All right, when we go even further north, or higher up on a mountain for that matter, we get into what's called tundra, which is cold for the bulk of the year, as you can see on our climate graph here. Their growing season is quite short. Um, they have permafrost, which is permanently frozen ground. So during the short growing season, the surface of the ground will thaw out, but you can go down just a foot or two or three, and you'll find permanently frozen ground. So this really limits what can grow there. Trees basically can't grow there because they can't get their roots down like a tree is used to doing because of the permafrost. So you pretty much just find herbaceous plants and shrubs, nothing terribly large. Um, there tend to be areas that don't get a whole lot of precipitation because of their high latitude and because they're dominated by, in general, high pressure systems. And so here you can see Iceland and Alaska. Yeah, no trees around, just relatively stunted shrubs and herbaceous. And by herbaceous, we mean non-woody plants. Okay. All right. So as we talked about before, mountains tend to show these same kind of changes depending on where you are to a certain extent. Where if it's a high enough mountain, of course, you'll tend to get tundra, and lower down you'll tend to get evergreen forests, and then lower down, depending on moisture levels, you might either have a grass habitat or a tree dominated, one's dominated by broadleaf trees. So you tend to see that same uh, uh, change with elevation as you do with latitude. All right, now let's continue a little bit. We'll talk about freshwater systems. We have a little bit of time here. Um, so streams and lakes. Um, and as is pointed out in your book in here, they are systems that connect terrestrial systems, the land, to marine systems, because of course water flows downhill, and the water that leaves the land will ultimately end up in the oceans, the marine systems, the saltwater systems. Um, and so one way we can think about freshwater systems is that one thing they do is here, we process the chemical elements from the land. So what do we mean by that? So the water falls on the land, it falls through the vegetation into the ground. Some of it will flow over the ground, some of it will get into the ground. Um, but as it's falling through the vegetation and over and through the ground, it can modify the chemistry of that system. And so it can cause certain or allow for certain chemical reactions to occur and take certain elements, certain compounds, certain molecules from the land into the water and out to sea. Um, so this is a schematic I grabbed off the web, and you don't have to memorize this by any means, but what it's kind of showing is that in these aquatic systems, there's a lot of chemistry, a lot going on because, again, the type of landscape you have will influence how the water is modified as it flows across and through the land and into the water. So if you have a relatively intact natural system, you have a certain kind of water chemistry, whereas if you have one that's been switched to modified to agricultural, you have a different kind of water chemistry, largely because of the use of things like fertilizers and pesticides, because those things can get into the water and change the chemistry of the water. Also, areas that have been developed into cities and towns with industries and houses and businesses, that can also impact the water, primarily through types of pollution that we generate and can get into the water. And of course, fertilizer pesticides would also be considered forms of pollution as well. So these things that get into the water, whether it's naturally occurring things or things that we produce, can impact the organisms there. Of course, you got the phytoplankton, the small photosynthetic um, organisms that live in the water, and then you've got the things that eat the phytoplankton, and the fish that eat the uh, various types of plankton. Um, and then, of course, some of this stuff gets back out to the oceans. And of course, some of it then gets back from the oceans into the terrestrial system through, of course, rain and snow. That's supposed to say rain, by the way. All right. So some terms here. When you have moving water, we call these lotic systems. Um, and when you look at a stream or river, of course, there's some parts of the rivers where the water is relatively shallow and moving much more relatively quickly, and other areas that where the water tends to slow down. It's still moving somewhat, but much more slowly. We know these as pools. Um, Riffles are important for water because when water moves more quickly and is agitated, it can add oxygen to the water. Um, Pools where the water slows down, if there's anything being carried in the water, any sediment in pools, the sediment will tend to be deposited. So the bottom of a pool or a part of the river that's moving more slowly will tend to have more sediment on the bottom, more mucks and stuff. If you were to walk in it would feel kind of mucky. Whereas riffles, because the water's moving more quickly, that tends to just be relatively rocky and not have a whole lot of sediment in them. Um, so the river or stream will have the main channel where most of the water is, and it's moving. Um, the bottom of the river or stream is known as the benthic zone. Don't worry about that term. We're not going to use that one. So you have the things that you have types of animals that tend to live in the main part of the channel, a lot of fish, for example. And then the benthic zones, the bottom dwelling organisms like um, crayfish and other creepy crawly things, if you will.